Okay, so today we're going to talk about arithmetic sequences. And arithmetic sequences is kind of our first application of linear equations that don't really involve using lines. Okay, so it is a linear equation and it uses linear equations, but we never really see it graphically. Okay, well, first we're going to start with some definitions. First of all, what is a sequence? And all a sequence is a sequence is an ordered set of numbers. An ordered set of numbers. So what does that mean? It means each number has a specific place in the set. Okay, so you can't rearrange them. They're in a specific order. So an ordered set of numbers. There's two types of sequences. Well, there's a bunch of different types of sequences, but there's two kind of main ideas off the sequence. First one being a finite set. A finite set means there's a set number of terms. A set number of terms. And all that really means is that a finite set ends. Okay, if you have a sequence that's finite, there's a beginning, there's an end. It doesn't keep going. So a set number of terms. And then an infinite set, you could probably guess, is when there's not, or infinite sequence is when there's no end. Okay, the sequence doesn't end. It'll just keep going in that pattern forever. All right, so we got our umbrella, we got sequences. A sequence is an ordered set of numbers. You could break down into a finite sequence, which is a sequence that ends, or an infinite sequence, a sequence that doesn't end. Okay. And there's a bunch of different types of sequences. In Algebra 1, we deal with two different types. And we're going to do the first one today, and we'll do the second one in a couple months. Okay, the first specific, named sequence is called an arithmetic sequence. Okay. An arithmetic sequence is a sequence in which each term after the first is found by adding a constant. Okay, so let's write that down. An arithmetic sequence is a sequence in which each term after the first term is found by adding a constant. And that constant is called the common difference. Okay, common difference. We use the letter D for that. Okay. So an arithmetic sequence is a sequence in which each term after the first is found by adding a constant, and that constant is called the common difference. Okay, and we denote that common difference with the lowercase d. So if you want to find the next term, you add the common difference. If you want to find the term after that, you add the common difference. And it's going to be basically it just means you're going to be adding or subtracting the same number each time to get to the next term. Okay. So arithmetic sequence is, it's the easiest one. You're just adding the same number to get to the next term. Okay, and that number is called the common difference. So let's look at some easy examples. Example 1. What is the common difference? And fill in the next three terms. Okay. So you're just trying to find the pattern in this set of numbers. We got 2, 5, 8, 11, 14, and then blank, blank, blank. So we have to figure out what the pattern is. And this one's fairly easy to see. To go from 2 to 5, you're adding 3. To go from 5 to 8, you're adding 3. 8 to 11, 11 to 14, plus 3, plus 3, plus 3. Okay, that's the pattern. Which means to go from 14 to fill in the next three terms, you're just going to do 14 plus 3, 17. 17 plus 3, 20. 20 plus 3, 23. And identify what the common difference was. The common difference, which again is the lowercase d, is a positive 3. Alright, so again, these are pretty easy. Same thing on the next one. What is the common difference? And fill in the next three terms. Okay, well the previous one had a bunch of numbers. Usually you need at least 3 numbers to establish a pattern. Okay, to make sure that pattern doesn't change. Alright, so on this one, we're going from 55 to 49, from 49 to 43. The pattern in this is that it's minus 6. Okay, so it's going to be minus 6 each time. So 43 minus 6 will give us 37. And 37 minus 6 will give us 31. And then 31 minus 6 is 25. Okay, so our common difference, our d value, is negative 6. We're adding that constant each time. Okay, so we say minus 6 just because by definition we're adding, so really we're adding a negative, or more practically we're subtracting. Okay. All right, so those are the easy ones. Find the pattern. Just you got to determine what the common difference is, and then use that common difference to find the next couple terms. Now, how does this tie back to linear equations? Well, it ties back because you remember what slope is. Slope is your constant rate of change. That's kind of what we're dealing with here with this common difference. It's the same number we're adding to get to the next term. Okay, so if it ties back to linear equations, there's got to be a formula that's also linear. Okay. And that's what's called the explicit formula. There's two types of formulas for arithmetic sequences. The first one we're going to do today is explicit, and tomorrow we'll talk about the second one, which is called recursive. The formula for an arithmetic sequence, okay, and this is one that you're going to have to memorize, and we'll explain what all these terms mean in a second, but let's write it down first. Okay. It's a sub n. Okay, so a sub n, that's an a lowercase a with a little tiny n next to it, a sub n, equals a sub 1. Okay, so it's a lowercase a with a tiny 1 next to it, plus n minus 1 in parentheses, and then times d at the end. Okay. All right, so what does all this stuff mean? Okay. The first thing we see is that a sub n. Okay. So what does a sub n mean? A sub n means the nth term. Okay. And n can be any number. Okay. A sub n is the nth term. Okay. And we'll specify that n can be any positive integer. So where n is any positive integer. So we're trying to find a sub n is going to tell us specific terms or specific values of a term in that sequence. So the nth term, that could be the 10th term, it could be the 50th term, the 100th term, the first term. Okay. So the nth term can be any number. All right, well, I mentioned the first term. The first term is part of the formula. The first term is a sub n, or a sub 1. Okay. So a sub 1 represents the first term in the sequence. All right, what's next? We got plus. We know what the plus means. We got parentheses n minus 1. Okay. That n minus 1, okay, we know what minus 1 means. N, in this case, it ties back to the nth term. N is the term number. So if you try and find the 10th term, n would be 10. If you try and find the 100th term, n would be 100. Okay. So it's always n minus 1. And then d we already defined. D was the common difference. Okay, it's what are you going up by to get to the next term. So the explicit formula for an arithmetic sequence is a sub n equals a sub 1 plus n minus 1 times d. Okay. So the nth term, a sub n, of an arithmetic sequence, where you have the first term is a sub 1, okay, and a common difference of d. What this means is you can find any term if you have the first term and the common difference. Now this is a formula you will have to memorize. Okay? And it's going to look more familiar here in a second once we do a problem and kind of simplify it a little bit. It'll look a little bit more familiar for us. But you will have to memorize this a sub n equals a sub 1 plus n minus 1 times d. So you'll need to know that formula. All right, so how do we use this formula? Let's look at a problem. Write the simplified equation for the nth term of the arithmetic sequence of 8, 17, 26, 35, ... So that ... means the pattern continues. All right, well, if you're trying to write the equation, you need to know two things. For the equation to work, we need to know the first term and the common difference. Okay? So symbolically, we need a1, a sub 1, and we need d, the common difference. So the first term and the common difference. Okay, this is the sequence. So we could see the first term. The first term is the first one that's listed. So a sub 1 is simply 8. It's the first term listed. Okay. We also need D, okay, the common difference. Well, the common difference isn't hard to find. You just have to figure out what the pattern is. How do we go from 8 to 17, and from 17 to 26, and from 26 to 35? The pattern in this, as you can probably tell, is plus 9. Okay. Between each of these terms, to get to the next one, is plus 9. Okay. So we got our common difference. That's all you need to write an equation. Kind of like, think about slope-intercept form. All you needed for a linear equation was a slope and an intercept. All we need for a arithmetic sequence equation is the first term and the common difference. Okay. So let's take our formula that we wrote down, the explicit formula. A sub n equals a sub 1 plus n minus 1 times d. Okay. Now, a sub n is going to stay a sub n. Okay. It's kind of like our y value. And n is our input. Is going to stay n. Okay. Everything else we're going to plug in. Okay. So we got a sub n equals a sub 1, the first term, is 8, plus n minus 1, it's going to stay n minus 1, times the common difference of 9. Okay. So again, all we're doing is we're plugging in, replacing a1 with the first term and d with the common difference. Okay. Now this is the equation. That's an equation. And it's an equation to find the nth term of this sequence. Now we do want to simplify things. We always want to write things in simplest form. So to do that, and again, most of you are pretty good with this. You see a number in front of a set of parentheses. Your first thought should be to distribute. Okay, so we're going to distribute kind of backwards because it's written out back. Okay, but it works the same way, distributive property. So we'll distribute that 9. That gives us a sub n equals 8 plus n times 9 is 9n. Negative 1 times 9, negative 1. And then all you have to do is combine like terms. We got an 8. We got a minus 9. They're on the same side of the equal sign. So you don't have to switch signs. You're not adding 9 into both sides. They're on the same side. All you have to do is combine them. 8 and minus 9 gives you negative 1. So our final equation for a sub n is equal to 9n minus 1. And that's your equation. Now that equation should look kind of familiar. That looks like y equals mx plus b. And I mean, that's why this is a linear application. That's a linear equation. That's basically in slope-intercept form. A sub 1 here is kind of like acting like our y-intercept. Okay? And the common difference is kind of acting like our slope. Okay? And an is our y value, and n is the x value. Okay? So this is x, this is y, and d is our slope. Okay. Now, a1 isn't the y-intercept. Okay, and we can see that in our equation here. The y-intercept, and that if that was slope-intercept form, would be negative 1. So it's not really the y-intercept. It's really more of a point. Okay, and we were going into point-slope form. Okay, so now what can we do with that equation? What this equation says is that the nth term of the sequence is equal to 9 times n minus 1. So for example, if we want to find the 18th term of the sequence, now one option is you could just do plus 9, plus 9, plus 9, plus 9, plus 9 18 times and figure it out that way. Okay? Or you could use the formula that we just found. So finding the 18th term means that we're trying to find a sub 18, which means our n value, our term number, is 18. So all we have to do is plug it into this formula. We're going to plug in, instead of a sub n equals 9n minus 1, we're going to say that a sub 18 equals 9 times 18 minus 1. And 9 times 18 is 162, and 162 minus 1 is 161. So what that means is that the 18th term of the sequence, a sub 18, is 161. So it could be written like that. So finding the 18th term, again, you could have done it by hand, plus 9, plus 9, plus 9. Now the next one you probably wouldn't want to do by hand. Find a sub 102. Okay. So what this means is we're trying to find the 102nd term of the sequence. So the 102nd term of the sequence, that means our n value is going to be 102. Okay, the nth term, the 102nd term, n is 102. Okay, all we have to do is plug in 102 into that equation that we had. So a sub 102 is equal to 9n, so 9 times 102, minus 1. 9 times 102 is 918, minus 1. So the 102nd term in this sequence, which again started at 8 and was going plus 9, plus 9, plus 9, the 102nd term is going to be 917. Now again, you could have done that by hand if you did plus 9, plus 9, plus 9, plus 9 102 times. Okay. Or you could just plug it into the formula. Okay, so let's try it for one more. Write the simplified equation for the nth term of this arithmetic sequence. -8, -6, -4, ... Okay, so pause it and see if you could plug in the correct values and get the correct equation from them. All right, well, remember, to write an equation, we need two things. We need to know the first term, and we need to know the common difference. Okay, so we need A1, and we need D. Okay. Now, A1, again, is easy. A1 is given to us. It's in the first term of the sequence is -8. So that means A sub 1 is -8. The common difference is also kind of given to us. You have to figure it out, but it's easy. How do we go from -8 to -6? How do we go from -6 to -4? Okay, we're adding 2 each time. So we got our first term, and we have our common difference, and now all we have to do is plug it into the formula. Okay. Now remember, the explicit formula is A sub n equals A sub 1 plus n minus 1 times d. Okay. And all we're going to be doing is plugging in. We're going to replace A1 with -8, and we're going to replace d with 2, and then we'll simplify. So A sub n equals -8 plus n minus 1 times 2. Okay. And then same thing as the last step. We're going to distribute the 2 and then combine like terms. So it leaves us with -8 plus 2n minus 2. And our final equation then is going to be, when we combine like terms, we'll have A sub n equals, we'll combine the -8 with the -2, and it'll give us 2n minus 10. So that is the equation to find the nth term of the sequence. So we can find any term in the sequence. Okay. So the first question here says find A13, A sub 13. What that means, again, that means find the 13th term. So all we're going to have to do is plug in 13 for n. So A sub 13 is going to equal 2 times 13 minus 10. 2 times 13 is 26. 26 minus 10 is 16. So A13, A sub 13, the 13th term, is 16. It's easy. It's real easy once you have the formula. Okay. Now again, for 13, 13 is kind of low. We could have just done plus 2, plus 2, plus 2 13 times. Doing it 120 times is not really feasible. So we'll just use the formula instead. We need to find the 120th term, which means 120 is n. So A sub n becomes A sub 120. 2 times n becomes 2 times 120. And then minus 10. Okay. And then just simplify. The 120th term, A sub 120, is 230. Again, the hard part's finding the formula. The rest of us is just plugging in values for x, or for n. Okay, it's like plugging in for x. Except for the last one. Okay. This last one is asking for what term is 144. Okay. So this is like in those problems where I gave you the output and you had to find the input. What input gives us 144? What n value is going to give us 144? So what this 144 is it's a sub n. Okay. So we're not plugging in 144 for n. We need to solve for n. Okay. So what we're going to do is we're going to plug in 144 as the answer, as the output. So 144 equals 2n minus 10. And then solve for n. This is going to tell us which term number 144 is going to appear at. Two-step equation here. Solve for n. Add 10 to both sides. Gives us 154 equals 2n. And then your last step of the one-step equation, divide by 2. So we get an n value of 77. So what that means is that the 77th term of this sequence is 144. Okay. So just like sometimes I give you the input, you have to find the output. Sometimes I give you the output, and you have to tell me the input. Okay. So same thing as linear equations. Okay. Just a different application of them. Okay. So again, the key to this is that an arithmetic sequence means it's a pattern in which you're going up by the same amount each time. Okay. You're adding the same number to get to the next term. And knowing the explicit formula is going to be important. So when we're writing an explicit formula, all we need to know is the first term and the common difference. Okay? Then we'll simplify that, and we'll get an equation that looks very similar to slope-intercept form.